We have to maintain a gas engine on most wheel lines. They'll run a gas engine, and so there's a certain amount of maintenance for those. Again, you have an air filter, you have fuel quality that you have to maintain, and lubrication, the proper oil, and the proper changing of the oil for that engine. Again, we have to keep them square. If they do start to get skewed in the field, if this line starts to go crooked and it starts to run diagonally across the field a little bit, there, that's really exaggerated. If the thing starts getting like this, we have to go out there and manually and physically square it back up. You move the mover back into square position, and then you have to literally pick the ends up and walk them back into place if it gets that goofed up. And they will at times if you have hilly terrain that causes them to get a little skewed, because if you run them back and forth enough times on a side hill, they're going to start doing some of that stuff to you. Okay? So we have to be aware that they can get out of skew, and you'll know that because they won't align with the valve. When they start misaligning with the valve, immediately you want to get them squared back up, because you let it get too severe, it becomes a real project. If you only have to move the ends about 5 feet or so, you can go back and square it up real quick. It does take a little time, but it's well worth the energy. Also might mean that you don't have your mover square to the line. The wheels of the mover may not be parallel to the main line. They may be, that mover may be tilted a little bit, so you have to square it back up as well. And again, if you do get a real tall crop or a lot of resistance to roll, you may have to help by rolling those end wheels back up into place at times, simply because of the resistance of the crop dragging against your lines. Operation of solid set is pretty much on and off. Here we have to worry about the controller or the manual operation of the valves. And then it's just timing. Do we get there at a proper time? Are we getting there? If it's a manual system and we need to turn the valves, cycle the valves at 3 o'clock in the morning, is somebody getting up and getting out there to do it? If it's automated, just monitor the controller and make sure that it has done its cycle, and occasionally it needs to be monitored. Somebody needs to spend a night out with it every so often to verify that it's been doing what it's supposed to do. And just watch it go through its cycle. And the other part of operation of solid set is occasionally you're going to have to flush the lines. We talked about that on components, so we put flush outs in them. And so there are opportunities if we're starting to have a lot of debris come down a surface, like we have a high water and we get a lot of silt come down a surface stream, and we've been pumping that silty water on. We need to be aware of that, and when the water clears up, we may need to run a flush cycle on all of our laterals out on those solid sets to flush those lines out and clean them out, so that we don't end up plugging up those end heads or the lines running to those end heads. In the drip, again, we have the big part of operation of drip are two things: keeping the filters clean and monitoring the emitters. We must, on a continuum, be monitoring the filtration. I mean, that has to happen every day, every day, every day. Even if it's automated, we still need to keep watch of the pressure. And all you have to do is have a pressure gauge up there and monitor those pressures to see that it's doing what it's supposed to be doing within its pressure limitations. If it's supposed to flush at 40 psi, for example, and it's at 45, we know we're okay. When it drops down to 40, we know we need to flush. If it's down below 40, we know it was past time to flush, and we better get in there and flush it. If it didn't automatically do it, maybe we need to close the times up automatically, flush more often. We got more of a load of debris than we thought we did. So the human element still exists even in the automated system. Somebody has to be making decisions. If it's flushing and there's only a 40, it's still at 45 and it flushes, we're flushing too often. We don't need to flush that often. We can back it off some on the automated controls. So that has to be monitored on a continuum. We also have to occasionally go down and monitor every emitter if it's a surface emitter system, so that we can see that they're working. Or if it's in a landscape, we need to go around and monitor every emitter at every plant to make sure they're working. And it takes time. It is labor intensive. People think drip is non-labor intensive. They are wrong. It takes a lot of labor to go around and monitor the system on a continuum. And if that needs to be done every 2 weeks or every month, whatever seems acceptable for the particular plants and the timing of the system, that's what has to happen. You let a plant go for a month in the middle of July, it's probably going to get stressed to the point it might not survive. So if you're in a landscape and you have a bush dependent on one emitter and it loses water for 30 days and it's 100 degrees out every day, it's probably going to be good and dead by the time you get back to check it. So you can check these things by other methods, and there are a couple of things we can do. We can look at infrared photography to check them. Taking a picture of the property really works good with orchards. You can spot every tree that is under stress because it's going to have a different shade of red on the picture than the others, and because all the pictures turn out in red and black and gray in infrared. All the pictures red, black, and gray. And the different shades of red determine how vigorous the plant's growing. The darker, deeper shade of red it is, the more vigorous it's growing. So if you see one tree out there that looks really off-colored, you know there's something wrong with that tree. Just go to the row, count down the row to the number of trees it is, and find out maybe it's the drip emitter, maybe it's a disease, maybe it's a bug that's attacked it. There are quite a few things it could be, but you certainly can check the water for it in that regard. Real easy. Another way to monitor that is with a temperature monitoring. They actually make a device that you can aim like with a, looks like a radar gun, that you can aim at a tree and pull the trigger and it'll tell you the temperature difference between the leaf surface and the ambient temperature in the air. And if the plant is healthy, it's going to have a slightly lower temperature off the leaf than the air temperature. If it's not healthy, the leaf surface is going to be hotter than the air temperature.
These things are cool.
And it works pretty slick. So